Hello everyone, welcome to the video on Digital RF Power Amplifier. In this video I will talk about the definition of the Digital RF Power Amplifier and how it differs from the traditional analog RF Power Amplifiers. We explain its structure and the basic concepts of it. So it's basically an introductory video for understanding Digital RF Power Amplifiers. So let's get started. So RF power amplifiers can be classified based on whether they are digital or analog into two types. It's just my own classification. Usually we classify it into class A, B, C, but for the understanding, let's say we classify it based on whether it's using analog signal processing or digital signal processing into two types. One is the analog Rfps and the other is digital or mixed signal Rfps. So, what is an analog RFP? Analog RFPs or analog RF power amplifiers are just a normal power amplifier which we see all around us. So, effectively, what it does is it just amplifies the signal from the input to the output, and this is what all the RF power amplifier theory is. Here in this figure, we can see a very simple schematic of a block diagram of an analog RF power amplifier. It consists of three stages, stage 1, stage 2, stage 3, and it has an input matching network and output matching network. The input power comes here and goes here, goes out here. Also it has some bias circuitry to control the biasing adaptively, and it also has the necessary supply. So it's just basic analog RFP. So now the question comes, what is digital or mixed signal RFPA? First of all, I would like to tell you there is nothing to be scared of. It is just the word which might scare some people, that it is extremely complex or something very different. No, it's not like this. It's basically the same concept. The only difference is that the way it is implemented and in which technologies is implemented. So let's look at it. So this is one schematic of digital RFPA. Here we call it, here it's from a publication where they design a dual band mixed mode polar power amplifier in bulk CMOS. So the first important thing about digital RFPA is that these PAs are usually made in CMOS technology because it's very difficult or impossible to manufacture them in GaN or other technology. So usually they're manufactured in maybe silicon, germanium, bulk CMOS, or these type of technologies which uses silicon as substrate, because what this amplifier is that it uses intensive amount of digital control. So there is an intensive amount of digital signal processing here. What it means is, here you can see that an amplifier is divided into a large number of unit cells. So it's not one just big power amplifier cell. Here you can see it is divided into 64 units, P cell 1, P cell 2, and all the way P cell 64. And then it can have varying sizes, and then it is controlled digitally through this block. So we can have a collection using digital control, which we can select different PS cells which will be on and off, and this means that by using different selection we can control the output power. So what we have done is we have divided a power amplifier into different sections. Each can have different size or maybe same size, it depends upon the usage. And then we can turn on and off all of those cells or some of those cells, and we can have a large number of combinations which can be turned on and turned off. Here you can see it's 2 power 7 combinations, and so there's a large number of combinations is possible. Also on the gate side we can have a large number of combinations on the gate control. So you can think of it as a very large number of bit control which we have to get a different set of power amplifiers which are on and off, and we can get different amount of AM to PM characteristics, AM to AM characteristics, as well as output power and efficiency. So we have a lot of control in our hand to tweak and to tweak the performance of the amplifier. So this is a fundamental concept. We divide the basic amplifier not into one big transistor, is divided into large number of chunks, and then they are digitally controlled. So that's all about it. There's nothing special about it. Here you can see, and this is the 1 unit cell. It is a very common cascade structure. We have two transistor M1, M2 in a differential configuration, and here we have the AM control is the cascade transistor control through this way, and we give the RF signal here. So that's all the concept. So why it is important? The important is that because we have so much non-linearities and different specs out here for 4G and 5G, that we are moving towards a lot of digital intensive stuff. When we talk about digital intensive stuff, it means that we want to get as much as control to ourselves using digital means. We don't allow much analog control. We don't allow it. We just take it all things in our own hand using digital control. So this mixed mode or digital power amplifier is one concept in this direction. So here, as I mentioned before, we divide a big transistor into a large number of small transistors, and then we can control the gate voltages, the drain voltages, and we can get different performances out of it. So that's the basic concept out here. There's nothing more special. Of course, when we implement it, it's quite complicated structure, and yeah. So in the above figure, we have 128 sizes of power device as was shown here. And we have a vector control. Yeah, so effectively it gives us more options and level of freedom. I hope this video was clear, a basic understanding of digital RFPs, and thank you very much.